So what about the evolution of virulence in parasites? So in terms of virulence evolution, we can describe parasites as differing genetically in ways that affect their impact on the host's Darwinian fitness. So remember, their impact on the host's Darwinian fitness, because it's a negative impact, we describe as virulence. So again, genetic variation within the parasite population. There's variation in terms of genes that have an impact on virulence. And when that's the case, when there are different virulence level alleles, then you can have evolution within the parasite population for some optimal level of virulence. Thus, parasites can possess different alleles that give rise to differing levels of capacity to reduce a host fitness, and these can be described as virulence determinants. Note that parasites do not harm hosts simply for the sake of causing harm to those hosts, but instead it is a byproduct, this harm, of parasite replication and/or parasites' mechanisms of transmission to new hosts. The parasite's job is to make more parasites and get those parasites to a new host to infect, and doing its job can have a side effect of harming the host. Because host organisms are both mortal and finite, that is, eventually they die, the host organisms eventually die, and they're only so large. There's only so much host organism to go around. The bottom line in considerations of parasite fitness is their potential for transmission to new hosts. So how do you make up for the fact that a host is going to die eventually, even if of natural causes, and that the host is only so large, there's only so many cells, for example, to infect in the case of a virus? The answer is that you can increase the amount of host tissue available to you if you can in fact find new hosts. And so a parasite, in order to be an ongoing presence within a community, has to be able to find new hosts. So its bottom line for a parasite in terms of the parasite's fitness is whether or not it's able to eventually find a new host. If it can't find a new host, if it can't release progeny that go on to find new hosts, then the parasite's fitness is essentially zero. Thus, parasites live and reproduce within host environments at the expense of host Darwinian fitness. They make the host sick. And they do so for the sake of being transmitted to new host environments. And the extent to which a parasite can be transmitted, is transmitted to new hosts, it really defines the parasite's fitness. Again, if the parasite is unable to be transmitted to new hosts, then its fitness is essentially zero. So we can return to economy and expediency in trying to understand these ideas of parasite fitness. The economical use of limiting resources is a case of altruism because of a trade-off between specific growth rate, that is, rate of biomass increase per unit time and also per unit biomass, and the growth yield, that is, biomass formed per amount of resource used. High growth yield, in other words, the economical use of common resources, increases group fitness. However, this can only be attained at the cost of decreased growth rate, which decreases individual fitness. So if you're not growing very fast, then your fitness, at least instantaneously, is not as high as an organism that is growing fast. But over longer time frames, what's important can be the total number of individuals that are produced rather than how rapidly they're produced. And that's, of course, Kreft. So in the case of virulence, parasite virulence, the common resource, what that's being competed for, is host tissue. So it's whether or not host tissue is being efficiently converted into new parasite progeny, or instead inefficiently converted. And symbionts can use that tissue either economically or expeditiously, with either economy or expediency. With greater virulence, that is on a per parasite individual produced, defining lower levels of economy or higher levels of expediency. So if you are a parasite and your job is to get in there and make as many progeny as possible as quickly as possible, that would be an expedient strategy. But that strategy can be an inefficient use of host resources, and to the extent any use of host resources results in harm to the host, then that can be a more harmful strategy to the host per unit parasite produced than a more efficient strategy.